Okay, everybody, welcome back to physics. We're gonna take a short little video time here to explain the period of a pendulum formula for that lab that you had completed. This is the second try. I know we did it in one class, but the video had no volume. So we're starting over. So here's your formula. T, big T, is for period. And in this case, it's for a pendulum, but big T is always for period, no matter what you do. Times 2 pi times the square root of the length of the pendulum to the center of the mass divided by little g. Okay, so I'm just going to write that up here so you know this. Hopefully you're able to take some notes, or maybe you don't need it. Length of pendulum, and that's in meters because that's our base unit for length, and distance is meters. Okay, and then we have little g here, which does change its gravitational acceleration. But that does change throughout the Earth, or around the Earth. It doesn't change by much, but the accepted value for lab is 9.81 meters per second squared. So we'll use that when we're in lab, but we'll use 10 when we're just doing our homework because we just use it so much that it's easy to subtract or to multiply and divide by 10. And they say you can use it on the AP test as 10, so it's good enough for us too. Okay, and this big T is period, and that is measured in seconds. Okay, so you guys went along and you made your pendulum, and you guys did a great job, or actually the last class did a great job because all of them were the same length, which is great. And if you look at this relationship here, you don't see a little m anywhere, do you? Little m would be for mass, and a lot of kids thought that if you would change the mass, it would change how long it would take to swing back and forth, but it didn't, and that's why it's not in the formula. And there's some good explanation on why that is. Might say that for another video, but keep in mind that a period is for one cycle of something that has a regular repeating pattern. So for your pendulum, it would swing all the way over, back, and then forth. And so when you get back to that same spot that you started at, or you can think of it as right before it starts to do again what it had already done, that's when one cycle is done. Okay, so the lab on number 12 asks about what the length of your pendulum should have been. So I'm going to just work you through the math on that. And I know you guys here in class with me, you haven't done the lab yet. So this is a little bit ahead of what you've done. And that's probably going to kind of happen this year, I'm feeling. So anyway, we wanted to make a 1 second timer lab. So we're going to have our period as 1 second. And really what we're looking for here is your length of your pendulum. Because you got it in lab and you measured it, but now we want to see what it should have been according to the numbers. See how well you did. So, do you guys know how to, are you good at algebra? You think? Because we do a lot of algebra in here. So I'm just going to run you through this one. We're going for L, right? So who can tell me what the first thing we need to do to solve for L? What's the first thing we need to do? Yeah, that's a good idea, to divide by 2 pi. I guess the way I would do this is to get rid of this radical first. So the opposite of a square root is a square, right? But you got to do that to everything on both sides. So your second line would look like period squared is equal to 4 pi squared times L over little g. Any questions about that math? Okay, so we're still trying to get L alone, so now we can do what you guys are saying. multiply by little g, right? To get that out of the denominator. Do you agree? So t squared times little g is equal to 4 pi squared over L, or times L. And then you said to divide by 4 pi squared. So the length of the pendulum should be equal to t squared times little g all over 4 pi squared. Okay, so now we're going to just put that into the formula. They say we just plug and chug then. Okay, so the length then is equal to, so the time was 1 second, right? So t squared is just going to still be 1. Little g, accepted value for lab use, is 9.81. And 4 pi squared, that pi is that perfect number. I'm not going to write it out. And so now you guys put this into your calculator and tell me what you get for a length. Okay, so the number we're coming up with here is 0.2485. There's more numbers to it, but that's what it rounds to. So hopefully your pendulum, your 1 second timer, is then approximately 24.85 centimeters, because that is the right answer. So now I know some of you guys are seeing this before you do the lab. So just double check it and see what happens when you make the length longer or shorter. You could add more or less math or mass. But this is what the answer should be. Okay, so that should help you with number 12 on the. Okay, so you'll use that formula for the math practice problems too. So you'll use it for more than just that lab. But there's also one more formula that I wanted to tell you about because it's also on the math practice problem. It's the period of anything is equal to the reciprocal of the frequency of that same thing. Okay, so frequency is measured in hertz, and 1 hertz is 1 cycle per second. So if you say something is 1 hertz, that means whatever's happening happens fully in 1 second. If you had something at 2 hertz, then that means that you'd have 2 cycles per second. Okay, so that's a pretty simple formula. The period in seconds is equal to 1 over the frequency of that object or that cycle. Now, the question is also, or the homework's also going to ask you about the frequency. So in order to solve this for frequency, you're going to have to get that frequency out of the denominator, multiply that by both sides, and then divide by t. So your frequency then is equal to the reciprocal of the period, just like the period was equal to the reciprocal of the frequency. So pretty simple equation, but there it is, and you'll have to use that also for your homework. Any questions? Okay, well, have fun with your homework.